What if I told you that for just 42,000 euros, which, by the way, is actually less than the price of a mid-range company car right now, a manufacturing plant could save 180,000 euros a year
I mean, I'd say,
and cut its reporting times by 70%.
yeah, see, that immediately triggers a healthy dose of skepticism. Like, when you hear numbers like that, the instinct is to just assume there's this massive, I don't know, hidden cost somewhere in the fine print.
Right. That was my exact first reaction, too. It sounds like one of those, theoretical best-case scenarios.
Yeah.
But those are the actual verified median figures we're looking at today.
Yeah.
So welcome to this deep dive. We're opening up a really, honestly, an incredibly practical new article from AetherLink.
Right, the Dutch AI consulting firm.
Exactly. They have these three main product lines: Aetherbot for AI agents, Eatermind for strategy, and AetherDV for development. And this piece of theirs is titled Industrial AI for Manufacturing SMEs in Turku, 2026 Growth Guide.
And the mission for our discussion today is really to decode how European business leaders, CTOs, developers, how you can actually pragmatically implement AI without bankrupting your organization. We're using Turku, Finland, as this ultimate blueprint for how SMEs, small and medium enterprises, are executing this digital transformation right now.
Because if you are a CTO or, say, a plant manager listening to this, you're likely feeling the squeeze, right? You've got a legacy machinery sitting on the floor, you're dealing with incredibly tight capex budgets, and your board is probably demanding some sort of grand AI strategy.
Oh, absolutely. And if we connect this to the bigger picture, European manufacturing is sitting at a really critical inflection point in 2026. I mean, we are seeing a shrinking skilled labor force across the entire continent.
Which is a huge problem.
Huge. And at the same time, the EU AI Act is no longer just this, theoretical framework being debated in Brussels. It's an operational reality. Manufacturers have to comply with it today.
Right, which is exactly why the focus on Turku is so illuminating. For context, it's Finland's fifth largest city, population of around 195,000, and it has this really deep history as a manufacturing hub. But they are entirely forward-looking.
Well, they have to be. I mean, the World Economic Forum in 2024 actually ranked Finland second globally in AI readiness. Turku is proving that advanced AI isn't just this luxury reserved for massive multinational enterprises anymore.
Yeah, obviously giants like Velmet Turku are doing incredible things there.
Sure, but what this AetherLink guide shows is that industrial AI is now an urgent, highly accessible necessity for, like, a 50-person metal fabricator to survive.
Yeah. So let's get into the nuts and bolts of how smaller companies are actually affording this, because that 42,000 euro number is just, it's such a hook. The article centers pretty heavily on something called the TeoÄly project.
Right. The TeoÄly project, it serves as this really landmark initiative in the southwest Finland region. Basically, it tracked 15 different SMEs, and these are spanning legacy sectors.
Like food processing, metal fabrication.
Exactly. Specialty chemicals, too, tracking them as they integrated AI into their production lines.
Okay, let's unpack this, because when I was reading through the technical architecture used by these 15 companies, I hit a detail that legitimately made me stop reading.
Oh, I know exactly what you're going to say.
The article highlights that they achieve these results using hybrid Excel and Python solutions. Wait, Excel?
Yep, Excel.
I mean, if I'm a CTO managing a high-throughput metal fabrication plant, putting my core operational logic into a spreadsheet macro sounds like a disaster waiting to happen.
Yeah.
Like, what about version control? If a floor operator accidentally deletes a cell, does my 42,000 euro system just crash?
That is the exact pushback every single technical leader gives when they first hear the word Excel in the context of industrial AI. But the spreadsheet isn't the engine, right? It's just the dashboard.
Oh, okay.
The operational logic isn't living in fragile macros. What AetherLink's AetherDV principles advocate for here is pragmatic technology selection.
So how does that data pipeline actually work mechanically then?
So you have Python scripts acting as this really robust, secure backend, and those scripts are directly integrated with the factory's legacy programmable logic controllers, the PLCs, and their SQL databases.
Got it. So Python does the heavy lifting.
Exactly. The Python layer runs the complex machine learning algorithms overnight. It's processing things like spindle vibration data or thermal fluctuations, and then it pushes clean read-only insights directly into the familiar Excel interfaces that the floor managers already have open on their desktop.
Ah, okay. So there is no new user interface to learn, and the operator literally can't accidentally delete the underlying algorithm because it's read-only.
That's the critical distinction. Bypassing a massive multi-million euro custom enterprise software overhaul, it allows for rapid time to value. You harmonize the data you already have and just deliver the insights in a format the team inherently trusts.
Right, because everybody knows how to read a spreadsheet. It's working with the reality of the factory floor, rather than waiting for some perfect, fully integrated, futuristic facility that, let's be honest, might never get built.
Yeah, it's just so pragmatic.
Now, the source also contrasts this hybrid approach with the shift toward agentic AI, specifically referencing AI Finland's 2026 initiative. And my understanding of agentic AI, like thinking about solutions like Aetherbot, is that it moves beyond just giving you a dashboard alert, right?
Oh, completely.
Like, if standard predictive AI is the check engine light on your dashboard, agentic AI is the car driving itself to the mechanic and ordering the replacement part. Is that the threshold we're crossing in Turku?
You have the mechanism exactly right. Agentic AI systems independently make decisions. They take physical or digital actions to achieve a specific goal. So in a factory, instead of just, predicting a machine failure and notifying a technician.
Which is what the Excel dashboard does.
Right. An agentic AI could predict the failure, autonomously order the specialized bearing from a supplier, and dynamically reschedule the entire production line to bypass the down machine. Wow, without a human clicking a single button.
That is a massive leap in autonomy. I mean, it's incredible. But the TeoÄly project companies didn't start there, did they?
No, and they absolutely shouldn't have. That hybrid Excel and Python setup was a necessary sandbox. I mean, you cannot deploy an autonomous agentic AI if your historical data is locked in a dusty filing cabinet somewhere.
Or siloed across 3 different legacy servers that don't talk to each other.
Exactly. Building those simple hybrid data pipelines first, it harmonizes the infrastructure and proves the financial return on a small scale before you hand over the keys.
And here's where it gets really interesting, because we need to talk about that financial return. Let's break down what that €42,000 median investment actually buys a company. Because the results from a 12-month deployment across those 15 SMEs were, well, they're staggering. A 22% reduction in unplanned downtime.
Which is huge for any factory manager.
Huge.
Yeah.
And a 12% boost in first-pass quality yield.
Yeah, that quality yield metric is particularly impressive to me. From a mechanical standpoint, achieving a 12% boost usually means you are deploying, like, computer vision or sensor fusion.
Yeah.
The AI is spotting micro defects or chemical inconsistencies in real time.
Right. So it allows the system to adjust the parameters before the part even moves down the line to the next station.
Exactly. You catch it before it becomes scrap.
It's kind of like installing a turbocharger on an existing engine rather than buying a whole new vehicle. You are squeezing significantly more horsepower and reliability out of the capital equipment you already paid for. And the source notes the ROI is realized in just 6 to 9 months.
Which is practically unheard of in industrial hardware cycles. But what's fascinating here is how this technological upgrade actually impacts the human workforce. Because, the prevailing narrative is always that automation of this caliber results in immediate layoffs on the factory floor.
Oh, absolutely. The classic robot taking my job fear, which frankly makes change management a total nightmare for management.
It really does. But Turku is experiencing the complete inverse of that. They are seeing a 45% year-over-year growth in AI-related job postings within the manufacturing sector.
45%? That's wild.
And nationally, according to traction data, Finland's overall AI job growth is at 60% annually. So the technology is augmenting the existing workforce. It's not replacing it.
I really want to press on that, actually. Because workers don't just blindly adopt new tracking software without friction. Like, nobody wants a camera over their shoulder. Yet the article points out that 89% of the shop floor operators adopted these new AI-augmented tools within just 6 weeks.
Right.
Was there really no pushback from labor?
Well, the lack of friction comes back to the interface design we discussed earlier. The system wasn't designed to track the workers. It was designed to track the machinery and relieve the workers of administrative burden.
Oh, okay. That makes sense.
By automating the routine data entry and manual reporting, the time spent on those tasks shrank from 3 days a month to just 8 hours.
Which directly attacks the regional skilled labor shortage, honestly. If you let your highly trained technicians actually focus on strategic troubleshooting and preventative maintenance rather than mind-numbing manual data entry, job satisfaction naturally goes up.
Exactly, and turnover goes down. It literally elevates the role of the technician.
Okay, so the tech is affordable, the ROI is proven in under a year, the workers are actually utilizing the tools, everything sounds perfect.
Right.
But the irony of these highly efficient automated systems is that their autonomy is exactly what triggers red flags for European regulators.
Yes. Here's the catch.
Right. The moment you remove the human from the loop to save time, you run headfirst into the EU AI Act.
And that is the core vulnerability for most organizations right now. The source highlights this 2025 European Commission survey, and it reveals that 58% of EU manufacturers currently lack formal AI governance structures.
58%. That's more than half of the continent's manufacturing base just legally exposed.
Heavily exposed. I mean, the EU AI Act categorizes industrial AI into risk tiers. So if you're using an AI tool just to optimize your supply chain logistics, well, that's generally minimal risk. But the moment an AI system controls a safety-critical process...
Like a robotic assembly arm moving heavy payloads.
Exactly. Or automated chemical dosing. It automatically falls into the high-risk category.
Because if the algorithm hallucinates or makes a bad call, physical environments get contaminated, or worse, a worker on the floor actually gets injured.
Exactly. And the legal obligations for high-risk systems are rigorous. You need documented conformity assessments, strict human oversight protocols, and highly transparent algorithmic decision-making. The danger here is that SMEs are deploying, say, predictive maintenance or automated quality control to save a few €1,000, completely unaware that they are triggering high-risk compliance mandates.
Right. Deploying an autonomous system without governance is kind of like trying to pass a corporate tax audit using a shoebox full of faded receipts. The EU AI Act wants to see the cryptographic math.
They want the receipts.
Yeah. And the article mentions specific technical requirements that I think are crucial for us to cover. Let's talk about training data provenance and model drift. Because if I'm understanding this correctly, data provenance is essentially the audit trail, right?
Yeah.
You need to prove exactly what historical data your AI used to learn its behavior, ensuring it wasn't, flawed or biased.
You're spot on. You literally need a verifiable receipt for the AI's education. If your system makes a decision that results in a flawed batch of, say, aerospace parts, regulators will want to see the exact data set that taught the AI how to identify a defect in the first place.
That's intense. And then there's model drift. I imagine that's kind of like a compass slowly losing true north because the magnetic field around it is shifting. Because a factory is a dynamic environment, right?
You're very dynamic.
Thermal expansion happens, machine parts wear down, raw material consistencies change from batch to batch. The AI is relying on an old map of the factory's conditions.
That is a perfect analogy. I mean, the model was highly accurate on day one because it perfectly matched the physical reality of the factory on day one. But by day 300, the physical reality has drifted, and the AI's accuracy degrades.
Right.
So the EU AI Act legally mandates that you have continuous monitoring in place to catch that drift before the compass leads you off a cliff.
I would say this sounds incredibly daunting for a 65-person company that just wants to fabricate metal faster. But this is where AetherLink's strategy arm, Eatermind, introduces the concept of an AI lead architecture framework.
And this raises an important question, right? How do you take these strict regulatory demands and actually turn them into a competitive advantage?
Because most CTOs view compliance purely as a sunk cost, like just a total barrier to innovation.
Totally. But the Aethermind approach flips that entirely. By utilizing an AI lead architect, whether that's an internal hire or an external consultant, you embed governance into the system architecture from day one. So you don't just bolt compliance on at the very end right before an auditor walks in the door.
So it's baked into the code.
It's baked into the culture and the code. And when SMEs address this gap early, they unlock a massive amount of trust. Think about it from a supply chain perspective, right? If you're a large multinational corporation looking for a specialized parts supplier, and SMEA has a fully documented EU AI Act compliant data pipeline, while SMEB is part of that 58% with zero formal governance, who gets the contract?
Well, SMEA wins the bid every single time.
Every time.
Even if they are slightly more expensive, because they are mitigating the multinational's downstream risk.
Exactly.
So let's bring this all together into an actionable blueprint. If I'm a CTO listening to this right now, I'm probably feeling a mix of extreme excitement about the 6-month ROI and sheer terror about the governance requirements.
Yeah, that's a very normal reaction.
So what does this all mean in practice? How do I actually start? Because the guide lays out a very clear 4-phase implementation playbook specifically tailored for European manufacturers. Phase 1 is the AI readiness assessment. The source stresses that before you buy a single piece of software, you have to look inward.
Right. This is where you identify your data silos. Which, by the way, is challenge number one for legacy manufacturers. You really have to audit your data quality across your SCADA systems, your maintenance logs, your quality control databases. Do they talk to each other? Are they machine readable? You also map out your process bottlenecks and assess your regulatory exposure under the AI Act.
Okay, so once you actually know where you stand, you move to phase 2, which is the pilot and proof of concept. Now, the recommendation here is to run this pilot on a single, well-defined process over a tight 3 to 4 month window. But I do have to push back on the sequencing here just a little bit.
Make sure.
Why build the pilot before locking down the full factory-wide governance framework? Shouldn't governance technically be phase 1?
Well, in a perfect, unlimited budget world, perhaps. But in reality, you need stakeholder buy-in. You have to mitigate the biggest fear in the boardroom, which is cost and ROI uncertainty.
That's true.
SMEs hesitate to deploy 50 grand without guaranteed returns. So by constraining the scope to one specific thing, let's say, thermal monitoring on a single injection molding machine, you can quantify the success metrics up front. The 3-month pilot literally proves the math.
Got it. And there's a huge detail in the article that I think should lower the blood pressure of every business leader listening. You do not have to bear the full financial risk of that pilot alone.
Yes, the funding.
The guide explicitly points out that government grants and low-interest loans are highly accessible right now through Business Finland and regional development agencies.
Finland's public sector is aggressively subsidizing SME digitalization. So tapping into those grants fundamentally de-risks the experimental phase.
Okay, so the pilot proves the ROI. Then you hit phase 3, governance and compliance integration. This is where those AI lead architecture principles take center stage.
Right. Now that you have a working model, you formalize it. You document the data provenance, you establish the human-in-the-loop oversight protocols for high-risk decisions, and you set up the automated alerts for the model drift we discussed earlier. You are essentially transitioning an experiment into a resilient, legally compliant operational system.
Which then gives you the foundation for phase 4, scaling and continuous improvement. You take the architecture that worked on that one injection molding machine and you start iteratively rolling it out across interconnected processes. And a key point the source makes is that you don't do this in a vacuum. Turku has this incredibly vibrant ecosystem.
Yeah, it's very collaborative.
You participate in communities like the Since AI hackathons, which already have over 500 members locally, or you engage at Turku Tech Week to share knowledge with peers.
It's a really robust cyclical playbook. You assess the data, pilot the tech, govern the system, and scale the impact.
So we have covered a massive amount of ground today. Let's distill this down. If you are listening and take only one thing away from this deep dive into the Turku manufacturing ecosystem, what should it be? I'll start.
Go for it.
For me, it is the complete myth-busting of affordability. We have this really ingrained industry bias that industrial AI is a luxury reserved for the Fortune 500. But the TeoÄly project proves mechanically that a €42,000 hybrid solution is entirely within a standard SME capex budget. By layering modern Python pipelines over legacy PRC infrastructure, it literally pays for itself in less than a year. The barrier to entry isn't financial anymore. It is simply a matter of taking the first structured step.
I love that. That financial accessibility is definitely game-changing. My primary takeaway builds on the regulatory side, though. It's viewing governance as a growth engine. The EU AI Act is fully arriving, so instead of hiding from it or treating it as this, tedious checkbox exercise, SMEs really need to embrace the AI lead architect mindset. By treating compliance as a strategic differentiator, you aren't just avoiding regulatory fines. You are actively winning customer trust and capturing market share from the 58% of competitors who are just too slow to adapt.
That is such a powerful perspective shift. Compliance is a sales tool.
Absolutely.
Now, before we wrap up, I want to leave you, the listener, with a final thought to mull over. The source mentions a concept briefly that I think is actually the seed of a much bigger strategic idea.
Right.
It talks about how AI adoption creates a multiplier effect within a region.
Right, the secondary markets.
Exactly. Businesses that invest in AI infrastructure end up demanding new training services, consulting support, and complementary automation tools. And that fuels entirely new secondary job creation. So we spent this entire deep dive talking about how to optimize your existing operations. But consider that multiplier effect. As these new ecosystems grow, how could your SME not just use AI to cut internal costs, but actually pivot your business model? Could you take the proprietary data pipeline you built to monitor your own machines and package it as a service to supply emerging secondary markets? Like, are you just going to be an AI user, or could you become an AI enabler in your specific industrial niche?
That is a phenomenal strategic question. It's really about looking beyond the immediate efficiency gains on the factory floor and seeing the new microeconomies that are forming right in front of us.
The landscape is shifting incredibly fast, and the opportunities are massive if you know where to look and how to structure your approach. For more AI insights, visit etherlink.ai.